Alright, so today in class we'll be discussing displacement, distance, and position. A lot of times the three concepts get interchangeable and people confuse them, so today I'll discuss the differences between the three of them. Okay, so position is the coordinate point of a graph. So first, draw our graph to help you all out, and then think of this as this will be our f of x, and we have 2 points, A and B. And these points themselves are your positions. So say we're going to start at position at point A. So for your displacement, we're going to draw a line to connect these two. Your displacement is your net area that you travel. So in this case, both your distance and your displacement are the same. However, we're going to change this. Your displacement here is still the same. You still end up from point A to point B. However, your distance, you're traveling a further distance along the line on the graph. Okay. So now, a lot of times you'll see displacement, distance, and position related to velocity. So first, up here we have our position function, s of t, and the derivative of your position function gives you your velocity function. So s prime of t equals v of t. And to find your displacement, it's the net area of your velocity function. It doesn't necessarily have to be a velocity function, it can be an interval function, but for now we're just going to write velocity for this example. So to find your displacement of your function, you take the integral from a to b, in this case v of t with respect to time. And over here we have a velocity over time graph. And to find the displacement, you would take this area under the graph, this integral, subtract it from this integral, and that you would find your displacement, your net area. However, if you want to find the distance traveled, it's the total area, it's the absolute value. So you take the same integral from a to b, however this time you take the absolute value of your function, in this case the absolute value of your velocity function, and on your graph you would add the two areas together to find your total area. Right. And as some of y'all may recognize this formula before, velocity is equal to displacement over time. So if you only have a velocity and a time, you can easily find displacement by multiplying velocity and time together, and you can see how they're related. Okay, so now we're going to do some examples right here. So we have our function f of x equals 8x cubed plus 4x squared minus 7x minus 4 on our interval from -2 to 4. And here's a quick sketch of our function f of x, and we're going to find the total area. As you recall, total area is the absolute value of the an integral of our function. And we're trying to look for the distance. So first, there's a couple ways to go about this. And if you have your calculator, you can simply type in your integral and the absolute value of your function. Or a lot of times, if you have to show your work, then you have to go through and actually find the zeros of your function and when the f of x changes sign. So when you set this equal to 0, you get that x equals approximately 0.958 and approximately -0.631. However, as you can see from this graph, it only changes sign at 0.958, so that's only 0 that we need to worry about. And then here's the complete value for the zero of the function. Make sure you do not round in the middle of the calculation. Once you find your 0, you want to store that in for your calculator. And now we're ready to take the integral of this function. So since distance is the absolute value, any value that's below the x-axis, any value that's negative, we need to put a negative sign from the integral to make it positive. So we have negative integral from -2 to a of our function f of x with respect to x, and then we can add it from the rest of the interval. So add that from a to 4 of f of x dx, and from there you can you'll be able to find the total area, the distance of your function f of x from -2 to 4. And when you evaluate this, it comes out to equal 549.041. Right. So now we're going to find the net area, the displacement of our same function, 8x cubed plus 4x squared minus 7x minus 4, on the same interval from negative 2 to 4. Now finding displacement is much simpler. You just simply take your integral from negative 2 to 4 of your function f of x with respect to x. Take your integral, and it comes out to equal 510. Because with displacement, you're trying to find the total area. So the reason why it's less than the value for the distance, because we're taking this area and we're subtracting it from this area underneath. So now we're going to find the position of a function at a point, and this time we relate a velocity function. So we have v of t equals 5t squared plus 3 of t. Doesn't necessarily have to be a velocity function, but we're going to use that for now. And we have our interval from 2 to 5. And to find the position at a point, x equals delta x plus x naught, where delta x in this case would be your integral, and x naught will be your initial position. So in this situation, at t equals 2, the particle is at 3. So s of t equals 3. And we're going to evaluate this function at t equals 5. So you take your integral from 2 to 5 of v of t et plus 3, where 3 is your initial condition, and this is your delta x. And when you evaluate this integral, it comes out to equal 229.5. And students, this is how you find distance, displacement, and position of a function.